we're going to be looking at the reaction of carbonyl compounds with cyanide. So what I mean by cyanide is this over here. So hydrogen cyanide is this molecule over here. If we want to look at cyanide ion, that's what we mean by cyanide ion. So there is a lone pair of electrons on that carbon there. There's a triple bond between our carbon and our nitrogen. Okay, so let's have a look at an example where we use cyanide with our carbonyl compound. I'm just going to go for an aldehyde. So ethanol. And I'm going to react that with hydrogen cyanide. This is going to form what we call a hydroxynitrile. So the functional group that we've got here is a hydroxynitrile. So where we have a carbon that's bonded to an OH and a cyanide. So I'm just going to write that here. Like so. Okay. Now, what you might not know is that hydrogen cyanide is a very toxic gas. Okay, we can't just have hydrogen cyanide in a lab. It's a lot better to make it in situ, and the way that we can make it in situ is by using sodium cyanide and sulfuric acid. Okay, so in terms of reagents, it's sodium cyanide and sulfuric acid that we use. That is going to release hydrogen cyanide in solution, and that's what's going to react with our aldehyde. Okay, so in terms of in terms of reagents, it's sodium cyanide and H2SO4 that we use. As you can see, we've got two reactants, one product. This is an example again of an addition reaction. So let's have a look at the mechanism behind it. So as always, our carbonyl, the C double bonded to the O, is a polar bond. The oxygen is delta negative, carbon is delta positive. Our cyanide that's produced is like this. So there's a lone pair of electrons on the carbon, negative charge on the carbon. Given that this has a negative charge and a lone pair of electrons, this over here is our nucleophile. So as you can see, this is going to undergo nucleophilic addition the same way that we do the reduction reaction of our carbonyls. So curly arrow going from our lone pair of electrons on our nucleophile going to the carbon delta positive. And then the carbon oxygen bond breaks, oxygen takes those electrons. Draw the product of that step. Like that. It's hydrogen cyanide that's present, so we also have, given that we have Cn minus, we also have H plus in the pot. So now H plus over here, lone pair of electrons, donate the electrons to the hydrogen ion, and therefore form a bond with that, and therefore the product of this, try and fit this in. It's not going to fit, sorry. Like Cn over here. Like that, and we formed our hydroxynitrile, and again it's undergone nucleophilic addition.